Next we have Tapia Cortez, who is also a PhD student at the University of New South Wales, and he is talking to us about adapting open pit mining optimisation techniques to design Martian mining machines for water extraction. Thank you, Carlos.
Thanks, Mike. Okay, good afternoon, ladies and gentlemen. Well, yesterday in a panel I had a question that it's very hard to put in the same table, in the same language, space industry and the mining industry. I think this slide is remarkable. So I guess it was listened to that. Yeah, as you can see, there are two schools of mining, one in the US and the other in Australia, working with space industry, with space agency. So I think that we have learned how to translate mining to space and space to mining. So yeah, we are very proud of it. So in terms of resources, this is what NASA said. This is what moved them to Mars. So, and this process, for me, seems to be quite similar to any colonization process. So, main example, Australia, the Americas, that people came not only to survive, but nowadays they supply raw material. So, makes sense. So this is not different than any colonization process, but what mineral resources are, if we can see on Earth, so we figure out a lot of things. No one knows what is happening underground, but we have several techniques that we can look at, make some modeling, represent some block models. For those who are not mining engineer, block model is just a geometrical representation of the quality and quantity of material beneath Earth, beneath the surface. We don't know, it's plenty of uncertainty. But even though we dig it, we mine it, we create projects. As an example, another question from yesterday. This kind of information or technique leads to mining company to invest billions of dollars. As an example, S11 in Carajás, Brazil, the largest iron ore deposit, or mine naturally, cost about $15 billion to produce 100,000 tons or 100 million tons of iron ore. A large amount of money. And if we look at Mars, it seems to be very similar. So we have some assumptions. We believe that there are some material inside. We can model it, we can explore, and still remain the same uncertainties. So the main question at that point is how? We know we have resources. We are not absolutely sure that they are, and the quality and quantity, but we need to know how to extract them to really know if they are resources, to become reserves and be useful. And one thing that we have heard today, in the last 2 days, is technology, mainly about equipment. So in our case, as a study case, we use the technology that it's currently used. Curiosity rover is the main example. Razor, developed by Kenneth Bates and Misri and Kara, that have proven the reliability to work in this harsh environment. So perhaps they are not the equipment that we will use in the future on Mars or the Moon, but they are the basis. But also we explore some techniques on Earth that we use it, like TBM or back in distillation, very efficient, low pressure. So he can use in that atmosphere that we have on Mars. Okay, but something that I heard yesterday, and it's remarkable from Ms. Martian, yeah, we need this technology transfer. We need to transfer that from both sides, from the mining to the space, and also space to the mining industry. We learned a lot about system engineer in the last 2 or 3 years with Cirque and the other guys that are working on the mining at school. So yeah, we need to do that. And to do that, we think, okay, do it. And for that reason, we developed this M202. Mars is not Star Wars, but it's Mars Mining Optimizer. what we aim is to simulate in a best way, in a more roundly way, what will happen in a mining operation on Mars. Compare technical requirements, and this is remarkable. We use geological and mineralogical data to construct information. So, what's the point? So, the model basically works as any mining project, or any project in a flowchart. So, we have the geology, which is the base, or equipment, capacity for processing, and optimization. To do everything works in a best way. So, but to do that, we need, as you see it in the left side, we need a lot of data, and we have a lot of data. So the thing is, we need to transfer this data on information. Otherwise, the large amount of data is useless, as normally happens in the mining industry. We have thousands of terabytes, but we don't know how to use it and how to read it, what it means. So this is M202. So basically, it works based on space. We are located. We use it around chaos as an example, but you can use it at any place. On the moon, yep. Other parts of Mars, absolutely. On Earth, yeah, perhaps you just need to update your equipment. And another feature, geological data. So we bring data from geological models that have done by remote sensing, which is the best information that we have, and use it. And also, we introduce some other features to let the system learn and understand what we are doing, like selecting has to have more selective method, as Tim said, and we introduce it. This is a normal mining technique. What happened? So we were able to create and recreate the topography of around cows. This is around cows. So the scale of color, so it shows the level of around cows in that region. And also, this is the block model. So all the data that we have on papers and numbers, graphically, they are. So we have grades of rosenite in that case, the percentage contained. So, okay, this is not magic how we did it, perfect. We get the information from research, from study, and translate it, move data to information. So at this moment, this tool works with very basic math, very basic machine learning algorithm like distance-based algorithm, because we figure out that in the future, this part which is light blue, somehow we will get some information and we can figure out what happened in between. So, well, we have limitation of this tool because it's 100% built on Excel, VBA, a very old-fashioned language. But anyway, other thing, Robert Miller told us on Wednesday night, mission control, we cannot pass through that cliff. So, okay, we considered that, and we put some restriction to calculate the path. So, and the yellow sign is a symbol of our mine operation. And at the bottom, the small one is a processing plant. It's far away. It's just for testing. And RZ are the restriction zone. So perhaps there is a cliff. There is some resources that we don't want to pass because we are another operation. We don't know, but we do. What's the goodness? So we can say on block model and also analyze what's happening in my topography, so I can avoid this kind of uncertain scenarios. And at the end, okay, I have my best path. So if I have to transport my material, I can avoid it. Yeah, my algorithm do it, the tool do it, but also he showed me, okay, this is what you will face. Perfect. So with that information, what you can see, okay, I need to think in an equipment that can run for 25 kilometers and can't climb and go down in a safety way. Or you can say, no, it's impossible, let's do it again. But we know we are using information, so we're creating knowledge based on information. What we use? The equipment that we have currently, we adapted them sometimes, for instance, and you can see this is not only use it what they have. It's like, okay, Miswi working with these parameters? No. We also think like a 5-year kid. What if? What if I change the diameter of the drilling machine, the length of drilling, the speed? I don't know. Perhaps I need to change the tie configuration. And this is the beauty of this exercise. The same for Curiosity rover, we suppose that could be used as a transporter. But on Wednesday after the presentation of the rover model, I said, okay, I need to rethink about what transportation means on Mars. Yeah, I need to be updated. Same, we can change parameters. Also, processing. So we are able to process a range of material. In our study case, we use rosenite in Remcaus, but we can, I don't know how to use it, but, well, you can see there is a list of minerals that we can process, and we have a processing model developed by Virginia Tech. He helped us in this model to understand what happened if I change the condition, if I heat it, processing a high temperature, low temperature, if I'm in the, I don't know, in the equatorial region or not, the efficiency that I'm going to have, and the losses, and also I can have a result. Okay, I need to dig certain amount of regolith, and also need certain amount of power. How to produce it? We don't know, but we need it. And this is the graph. What demand material that we have, the water that we can recover, and the water that we lose. At the end of the day, we have a curve like this that tells us, okay, you cannot see it, but they are based on different mining methods, which in this case are basically focused on surface mining, because Reyes and Mesui are designing for regolith. We can have the number of equipment and the production rate of each one. So yeah, perhaps we can say, okay, 200 Mesui, it's impossible. But perhaps not. If they are 10 by 10 by 10 centimeters, 200 seems to be good. Or we can think about, okay, we need to establish a colony close to a mining site, not 25 kilometers away like we do on Earth, but perhaps 500 meters at our side. We don't know. These are the answers that we need to, this is the tool that will help us to answer that question. So also the use of razor, yeah, seems to be very efficient. Go ahead. What do we need to improve that? If we increase, I don't know, the size of the speed, what will happen? And this is important because it also provides a lot of technical output before to construct any equipment. So, and we know that we need to think about what we need actually for that condition. So otherwise, we can go and create a fantastic equipment, but perhaps it's not that useless. Perhaps in our own counties, but in other regions could be. So these kind of guidelines are extremely important. Just to finalize, it helps us to analyze the performance of the missions on Earth from a mining point of view, but with space subtitles. We can plan our missions, so anticipate some hazard condition or unknown, compare the performance between different equipment or mining method, and yeah, guidelines for equipment. Something that we need to do, and this is something that the aim of the tool had, but we couldn't because the environment is to use machine learning. Reinforcement learning, it's one of the main components perhaps for training or optimize or select the model based on the data that we have from rover missions. So, and also for geology, like, I don't know, other classification like perceptions. And yeah, I think that we are in the right way. So, well, thanks for your time.
Thank you, Carlos. Do we have any questions for Carlos? Yes.
It's a really interesting tool, and I'm wondering, is it available for people to play around with? And
Well, this is not available for, not at this moment, but we have a similar tool that it's called WM3, which is in our website, and you can download it. Just Google WM3, and this is for free. It doesn't have the fancy topography and block model features, but yeah, you can take a look at Mars in a strategic point of view. Yep.
Yes.
So I'm trying to understand something which may be my lack of knowledge of terrestrial mining and how it's done. So I need your advice. To me, it seems like the model is only as good as the input data. And that's true of any model. So the input data on Earth, you get it by drilling, right? Exploration, drilling. And then you map your resource by the cores, right? Is that how you do it?
Yep, yeah. You have access to physical sample. That's
so we don't have that.
Yeah.
So does that mean we have to put down a deep drill before we can ever start assessing the resources? Is that the answer, or are there other ways of assessing the resources?
Okay. Well, I can tell you that, yeah, indeed, if you want to increase the confidence of your data, of your model, yeah, you need to drill. But any case, assure you that what you drill, you will find on the ground first. And there are other techniques that like remote sensing or other kinds of technique that could help you to define your deposit. And this is why I stressed the necessity to include powerful, new, untraditional techniques for resources. What we use right now on Earth are highly dependent on drilling samples. But we are not using our knowledge. So the geology on Earth could be similar to on Mars. We are in the universe. How they create iron ore, the process could be similar, silica could be similar, and we have the patterns. And we exactly know how they were formed because we drill it, we dig it, and we have all this data. So what we need to do is to use this data, transform in information, create knowledge, and put it on Mars, and compare them, and say, okay, it looks like, and then focus on one. So I'm not telling you that you don't need to drill, but Mars is a huge planet for exploration. So we need to use our information, our knowledge, our data to set the target.
Okay, thanks.
My pleasure.
Thank you. We might have to move on with running a little bit behind, I think. So,
Okay, if there's any questions.